Hello students. Welcome to today's class. We are going to talk about speed and velocity. Before we proceed with today's lesson, remember, in our previous class we learnt about the concept of non-contact force, the various types of non-contact force. By the end of this lesson, you should be able to know the concept of speed and velocity. Know the difference between speed and velocity. Now, without further delay, let us dive into today's topic. Speed is a scalar quantity that refers to the rate at which an object moves or covers a certain distance. It is a measure of how fast an object is moving without considering the direction of motion. It is measured in units, such as meters per second or miles per hour. The formula used to calculate speed is speed equals to distance divided by time. Note: speed does not take into account the direction of motion, so two objects can have the same speed but be moving in opposite directions. Next, we are going to deduce the speed of motion from the slope of a distance-time graph. Before we deduce the speed of motion on a distance-time graph, let's learn the concept of a distance-time graph. A distance-time graph is a graphical representation of the relationship between the distance traveled by an object and the time taken to travel that distance. A distance-time graph consists of the following. Distance. The distance traveled by the object is plotted on the vertical axis, which is the y-axis. Time. The time taken to travel the distance is plotted on the horizontal axis, which is the x-axis. A gradient or slope. The slope of the graph represents the speed of the object. A steeper slope indicates a faster speed, while a shallow slope indicates a slower speed. If you have a flat horizontal line, it means the object is stationary, meaning the speed is 0. If you have any other straight line, it means the object is traveling at a constant speed, because a straight line has the same steepness throughout, so its gradient isn't changing, meaning its speed isn't changing. However, in a curved line the gradient changes. If the line curves and gets steeper, it means its gradient is increasing, meaning its speed is increasing. This process is known as acceleration. If the line curves and gets less steep, it means its gradient is decreasing, meaning its speed is also decreasing. This process is known as deceleration. Now, let's solve a practical question, so we can get a better understanding. A car travels a distance of 120 kilometers in 3 hours. Plot and interpret the question on a distance-time graph and then calculate its speed. Remember, distance is plotted on the vertical axis, which is the y-axis, and time is plotted on the horizontal axis, which is the x-axis. Next, we will have to decide a scale for each axis. Let the x-axis be 1 centimeter to 1 hour, which is 1, 2, 3, 4, and 5. Let the y-axis be 2 centimeters to 40 kilometers, which will be 40, 80, 120, and 160. Now we will have to mark the point at which our distance and time meets. Then we will draw a slope from 0 to the point. Now we are done with plotting the graph, so we will need to calculate the speed. Remember, the formula used to calculate speed is distance divided by time. And the distance is 120 kilometers, while the time is 3 hours. So, the speed will be 120 kilometers divided by 3 hours, which will give us 40 kilometers per hour. Next, we are going to talk about velocity. Velocity is a vector quantity that refers to the rate of change of an object's position with respect to time, including both the speed and direction of motion. In other words, velocity is a measure of an object's speed in a specific direction. It is a vector quantity, which means it has both magnitude and direction. It is measured in units, such as meters per second or miles per hour. The formula used to calculate velocity is velocity equals to displacement divided by time. For example, a car travels east, covering a displacement of 300 kilometers in 2 hours. What is its velocity? Remember, the formula used to calculate velocity is displacement divided by time. and the displacement is 300 kilometers, while the time is 2 hours. So, the velocity will be 300 kilometers divided by 2 hours, which will give us 150 kilometers per hour east. Note: velocity includes both the speed, which is 150 kilometers per hour, and direction of motion, which is east. Next, we will talk about the difference between speed and velocity. Speed and velocity are two fundamental concepts in physics that are often confused with each other. Let's look at the differences between the both. Speed is a scalar quantity, which means it has only magnitude but no direction. While velocity is a vector quantity, which means it has both magnitude and direction. Speed is always positive, while velocity can be both positive and negative. Speed is calculated using the formula distance divided by time, while velocity is calculated using the formula displacement divided by time. Great job, students! I have 2 assignments for you to work on. Number 1. List 4 differences between speed and velocity. Number 2. A train moves a distance of 900 kilometers for 3 hours. Plot and interpret the question on a distance-time graph. Calculate its speed. Isn't it easy? Before we end today's class, let us summarize on what we learned. Today, we learned about the concept of speed and velocity, the difference between speed and velocity. We also learned how to plot a distance-time graph. Alright, students. Great job today. In our next class, we are going to talk about rectilinear acceleration. Thanks, and goodbye.